This script implements a light GBM based approach for time series forecasting across load, solar, and wind datasets. It starts with the import libraries and then we define the parts. Then we give the configuration, we define the input windows as 168 and forecast horizons as 24. The light GBM parameters like number of estimators and depth and learning rate are tuned to balance bias and variance. We take the build sequences where the time series data is converted into supervised learning format using sliding window. Each sample contains past 168 time steps and predict the next 24 values. We use the naive baseline to compare the performances learned in the supervised learning. The core part is the run LGBM OOF function. Here we use time series split for each walk forward validation. For each fold, normalization is done using only training data to prevent leakage. After that, the input is flattened from 3D to 2D since the light GBM expects tabular data. A key design choice here is that we train 24 separate models, one for each forecast horizon steps. So instead of predicting all outputs at once, each model specializes in predicting a specific future time step. During training, early stopping is used based on validation data to prevent overfitting. After each fold, predictions are stored as out of fold outputs and the best performing fold is selected. It models and normalization parameters are saved for later use. Finally, the evaluate function compares light GBM predictions with a naive baseline using matrices like MAE, RMSE, SMAPE, and correlation. Additional statistical summaries and plots help analyze performances across horizons and error distributions. Overall, this approach treats time series forecasting as a supervised learning problem using gradient boosting with careful validation and strong baseline comparison. Each model captures time series pattern directly and differently, but all were evaluated using proper walk forward validation and compared against the naive baselines.